How do amorphous solids form when freezing? Imagine pouring a hot liquid into a mold and then cooling it down rapidly. Sometimes, instead of forming a neat, ordered crystal, it turns into a jumbled, glassy solid. That's what happens when amorphous solids form during freezing. Usually, when a liquid freezes, its molecules settle into a regular pattern called a crystal lattice. This orderly arrangement makes a crystalline solid. But under certain conditions, the molecules don't have enough time to organize properly. Rapid cooling, often called quenching, is the main reason. When cooling happens very fast, molecules lose mobility quickly and get stuck in a disorganized state. They don't have the chance to form those neat, repeating patterns. Instead, they become frozen in a random, glass-like structure, creating an amorphous solid. This process involves bypassing the usual phase change where molecules arrange into crystals. Normally, as a liquid cools below its melting point, molecules slow down and settle into a crystal lattice, reducing the system's free energy. But if cooling is faster than the molecules can move and rearrange, the system falls out of equilibrium. It skips the crystal formation and turns into a glassy, amorphous state. This is related to the glass transition temperature, which is the temperature below which molecules become so sluggish that they behave like a solid without crystallizing. In practical terms, amorphous solids form in many areas. For example, in food preservation, rapid freezing prevents ice crystals from growing large, trapping solutes in a glassy matrix. This helps maintain texture and stability. In pharmaceuticals, quick freezing during freeze-drying creates amorphous drug forms that dissolve faster and improve absorption. Water itself can become amorphous ice if cooled very quickly or under high pressure, resulting in a non-crystalline form called amorphous solid water. Overall, controlling how fast you cool a liquid and under what conditions determines whether it becomes a crystalline or amorphous solid. When cooling is rapid enough, molecules don't have the chance to arrange themselves into an ordered pattern. Instead, they stay in a disorganized, glassy state. This process links thermodynamics, which looks at energy and stability, with kinetics, which considers how fast molecules move and rearrange. That's how freezing can produce either a regular crystal or a jumbled, amorphous solid.